Okay, Bismillahirrahmanirrahim. Okay folks, this is my take two, my second go at this particular topic, because for question number one, question number two, we had some technical issues with the saturation of light and the recording of the, when we were doing this originally for the class live. So I'm redoing those questions. Hopefully we'll get a better light condition in this new video. So please bear with me. So in these particular video, for the next two questions, I won't be talking to my students. This has been done late in the evening as a redo. Okay, right. So we're looking at Edexcel style question, GCSE Mathematics A, on the topic of bounds. It's aimed at the higher tier, 1MAO 2H syllabus. Question number one. W equals the square root of x over y. Here we're given some of the information. X is equal to 5.43 correct to 2 decimal places. Y is equal to 4.514 correct to 3 decimal places. By considering bounds, work out the value of W to a suitable degree of accuracy. That's what it should say over there. You must show all your work in and give a reason for your final answer. Now, we've got here 2 and 3 decimal places in our question. So I'm going to decide that we're going to give 2 decimal places in our answer. Because scientific calculations tend to have 2 to 3 decimal places. They use 2 and 3. We can use 2 for our answer. Now, x equals 5.43 correct to 2 decimal places, and that's what y is. Now, in order here, they haven't told us in this particular question to consider getting W upper bound or W lower bound. They've just left it open to us, to the student, by considering bounds. So this bit here, it sounds open-ended, but it's actually referring to one particular style of doing question where you looking at upper bounds now. Now upper bounds can be, for example, we could have W upper, or we could have W lower. Normally the question they say to you, work out this one or work out that one. Now because they said by considering bounds, work out the value of W to a suitable degree of accuracy, what they want us to do is to do both of them and to do an average. So we need to work out what the maximum could be, what the smallest could be, and then average them to give us the final answer. That's what we need to do. That is what this part of the question means, by considering bounds. They haven't told you exactly what they want you to do, but the interpretation of this is they want you to work out the upper bound and the lower bound and to average it to give you like in between value. That's what this type of question means. So let's have a look. Now, if I want to look at W upper, so W upper. Now W upper will be equal to, if you have a quotient here, division, to get the maximum number out on this side, from our formula W, we need to get x to be as big as possible and y to be as small as possible. Think of it as money that you have. If you increase them, this x represents the money that you have, y is the number of people. If you make the money as much as you can and reduce the number of people, each person will get more. So you will increase the answer. So x will have to be x upper and the y would have to be y lower. That will give us the upper value of this W here in this formula. Okay. Now, if you want to work out the W lower bound, the smallest this W could be, the lower bound of it. In order for us to get a small answer when we're dividing, we want to make the top number as small as possible and make the bottom number as big as possible. So when you divide a small number by a bigger number, or by a big number at the bottom, you get a smaller answer. So in that case, that will be x lower divided by y upper this time, and then square root it. Okay, so that's W, that's what we've got to work out, and then we've got to add them and divide it by 2, and that will give us like a W average. That will give us upper, lower band average. So we're going to work this one out, we're going to work that one out. We're going to add them up. And then we're going to divide it by 2. That's the idea. So we need to start looking at what is the upper and lower bound of these particular values. So we know double check let's play the video. Okay, now let's have a look. Now x is equal to 5.43 cut to 2 decimal places. Okay, we're going to draw a line here and we're going to put here 5.43. Y is equal to 4.514. Put a line here and 4.514 goes there. Now, because we're doing 2 decimal places, so the best way to look at these kind of questions is you've got 5.43, the next value would have been, okay, is 5.44, and the previous number would have been 5.42, so we're counting up in hundredths. 5.43, the next value that we could get as answer is 5.44, and the previous one is 5.42. So the nearest 2 decimal places means to the nearest hundredth. So in a sense, once we have done our little number line like this between here and here is a hundredth. That width is a hundredth, and that width there is half of a hundredth. So it's 5.43. If you go halfway between this number and that number, that'll give you 5.44. Pardon me, 5.435. Okay, and if you go half between 5.42 and 5.43, that will be 5.425. So far we've already got now x. This is now going to be x the lower bound and x upper bound. Okay, so let's turn a different color. Right, here we go. Now, similarly, if you're looking at the y, is 4.514 cut to 3 decimal places. 4.514 is here. Let's look at the next number. If we're counting in thousands now, the next thousand is going to be 4.515. So 1 up from the 4. That one's going to be 4.513, which is going to be 1 down from the 4. Now, to the nearest thousandth means that the distance here is going to be 1,000th, or we're going to go halfway up to the next number. So so the upper band will become 4.5145, and this value here will be between these two halfway, which will be 4.5135. that will take you between here and there. So now we have our y lower bound and y upper bound. Here they are. Okay, I hope you can see those numbers clearly. Just double check that on the video. Okay, right. What I'm going to do now, okay, some of these writing might be a bit tight. I'm going to copy this out in a clean space over here. Hopefully we can see them a bit better. Okay, let's look for a nice clean space. Okay, what we're trying to do now, I'm trying to reduce this clutter from here and from here and put it nicely and clearly over here. And as I do that, I'll start rubbing off the other values. Okay, right. Let's get rid of these from here. Okay, hopefully we can. Okay, right. Just give me one moment. We are going into power save mode. Just give me one moment while this all comes back up. Okay, right. So now the x values are here. That's the actual value that's measured. That's its upper bound value, that's its lower bound value. So we can write down here. Just choose x lower, x upper. These are the y values that was given in the question to the nearest thousand. So its highest value could be this, and the lowest value here. Remember, we're counting in thousands from 4.514 to 4.515, and then we're going halfway between that and that. So that's half of 1000 in essence. So this is going to be my y lower, this is going to be my y upper. Okay, now what I'm going to do, because at the moment, as you can see, the spacing is limited, and that's my idea. I'm going to now start to rub off the letters and start putting these values in there. So just bear with me, please. So let's go with this first of all, and this. So I said earlier to get by considering bounds. So I'm going to consider the upper bound for W, the lower bound for W. I'm going to add up these two possible answers and divide it by 2 to get an average of the lower bound. So let's have a look what the calculations are. It says here XU, X upper is 5.435. So 5.435 goes in here. And Y lower. Well, Y lower is 4.5135. 4.5135. And this part here will give us the W lower bound version of the calculation. Consider X, that's going to be the X lower bound divided by Y upper bound. So the X lower bound is here 5.425. That goes instead of this. It's 5.425. And this is Y upper bound. Y upper bound over here 4.5145. Okay, so to get our answer, we're going to put this calculation into the calculator and work our answer. Okay, that's looking nice and clear. Okay, right, let's get our calculator loaded up, our calculator software. Okay, that. Just give me one moment, please, folks. Okay, right. Okay, our calculator software is here somewhere. Right, here we go. Okay. Shift, menu, math mode. Good. Okay, right. So we need to put this calculation in. Can we put in as we see it at the moment? We should be able to put this calculation in literally as we see it. Now, in these, so hopefully we won't get any rounding errors. We get a nice, clean, crisp answer. And then we write that to 2 decimal places. Here we go. So let's enter in, I'm going to rub this part off over here, because this is actually in our way. Okay. Here we go. Right, we want to have a fraction, and we're going to have a square root, square root, and we have another fraction inside the square root. Okay, and that's 5.435. 5.435. Then we use replay to bring the button down. Then we put type this in. 4.5135, and then plus. Use replay to bring it out. Okay, plus in, and then another square root. Shift square root, and then we use a fraction, press the fraction button. Now 5.425. Use replay to bring the cursor back down to the bottom. Type in the bottom number 4.5145. So now, so far, if you look at it here, exactly as we have here in our calculation, the upper value of W and the lower value of W rounds, I've entered them identical into the calculation. We need to go to press replay to bring the cursor down to the bottom so we can put the 2. Because what we're going to do in this particular instance, we're going to work out the average of the upper and the lower bounds. And type in 2. And inshallah, hopefully this should give us the right answer in one go. So that gives us an answer of, all of this gives us an answer of 1.0967. Now, scientific calculations, we're going to round it off to 2 decimal places. So that's my last digit, that's my decider. Because it is, if it's 5 or more, we add 1 to the last digit. So 9 add 1. So 9 add 1 will give you 10. 0, and that will give you 1.1. So my final answer is 1.1022 decimal places. That's the final answer to this question. Okay folks, I'm sorry this question was a bit long-winded, but I wanted to explain to you each individual part. We had to rewriting some of the stuff to make it look more clearer. And then the calculator part, obviously when you're going to be doing exams, you'll be doing it in a few minutes. Okay, but I just wanted to make a nice, clean, clear video. Okay folks, I hope this particular question helps you when you're doing your examination question. Now I'm going to move on to question number 2. Okay, let's move the calculator to one side. Alright, so that's the end of that question number 1. Let's move on to the board. Okay. Okay, question number 2. Right. Here comes question number 2. An arrow is shot vertically upwards at a speed of v meters per second. A height h meters to which it rises is given by this equation. Height is equal to v squared divided by 2g, where g meters per second squared is the acceleration due to gravity. V is equal to 24.4, correct to 3 significant figures. These 3 significant figures, folks, don't get scared over it in examination. 3 significant figures, all it means, if you look at this question here, that they rounded up to the nearest tenth. That's what it is. Students see this and they freak out in the exam. Oh no, 3 significant, what does that mean? How do I understand that? Look at the number 1, 2, 3 significant figures. So the third significant figure is the most important one in this question. That means that this number 24.4 has been rounded off to the nearest tenth. So when we do a number line, it's going to be easy. G is equal to 9.8 correct to two significant figures. So that's the first significant figure, that's the second significant figure, that's the most important one. So two significant figures means the same thing as in the previous question. It's been done to the nearest tenth. Even though here they use 3SF and here they use 2SF, it's to do with where is the second significant figure. It's there in the tenth position. Where is the third significant figure? Where is it? It's there in the tenth position. So we're talking about tenths. We're talking about tenths. So it goes right down the upper bound of G. Okay, let's have a look. So I'm going to use the space here. So we say G is 9.8. It's been quoted to one decimal place or two significant figures per second. So that's the most important digit. Let's look at the next one up. If I carry on in tenths, the next one will be 9.9 and the one before that will be 9.7. Okay, right, and that's our original value there. Now, when we can say done to two significant figures, that means to the nearest tenth. We've rounded up to the nearest tenth because that's the digit, that's the important one. So, in a sense, this distance here is 1/10. That to the nearest tenth. There's half of a tenth this way and half of a tenth that way. So the easiest way to find out the upper and lower band is literally to go between here and there, halfway. So that's 9.8. So that's 9.85. That's 9.7, 9.8. Halfway between these two is 9.75. That's it. There's nothing to be scared or worried by these questions. So this would be called G lower, and that would be, sorry, G upper, not the capital G. Okay, because gravity low, that's the our lower band, that's our upper band. It goes right down the upper band of G, well, the upper band is just 9.85. That's the answer for this first question. Okay. Right. Now I'm going to move the question up and down a bit because I can't see the bottom of the question. It goes, calculate right down the upper band of G, which we know is 9.85. Which we said is 9.85. That's part 1. Part 2 says calculate the lower bound of H. So now they've told us specifically what they want us to do this question. In the previous question they said by considering bounds, so it seems that they left it open, but what they really want you to do is do upper, do lower, work at the average, which is long-winded. Here they're being very specific. In most questions are like this style, calculate the lower bound of H. So that should be, we should be able to do that straightforward. Okay, so let's go to that. Okay, so our original formula is H is equal to V squared divided by 2G. Now, if we want to work out the lower bound of H, again we have a quotient. We have the top number divided by the bottom. If I want H lower, if I want to work out the smallest the H could be, what we need to do in that case, to get a small answer with a division, you make the top answer as small as possible by considering this lower bound, and you make the bottom answer as big as possible by considering its upper bound, because a small number divided by a larger number gives you a smaller answer. Okay, so that's going to be my idea behind the question. We've already done the G lower, G upper, and we'll use a G upper. So this value here that we had for the answer for the first part will be used directly into our formula, but I don't have the VL yet, so we need to look at the V and look at the VL. So here we go. Let's have a look at that then. Let's do up here. So the V value is 24.4. Correct to 3 significant figures. First SF, second SF, third SF. So the third significant figure holds the 10th position. So I'm going to count now in tenths. So the next tenth after 24.4 is 24.5. The previous tenth to 24.4 is 24.3. Now the nearest tenth, so this is our original value, the nearest tenth means this width here as number of tenth. So that's half of 1/10, and that's half of 1/10. So altogether that's 1/10, no 0.1, that's worth. The easy way for us to interpret that is, I'm going to go from 24.4 to 24.5 halfway. That will give me 24.45. That will give me the upper, and if I go half between these two, that will give me the lower bound. So 24.35. So we can say here that this is going to be V lower, the velocity lower, and the velocity upper bound. Okay? So we're now quite quickly using a number line, be able to establish exactly what the upper and lower bounds are. Regardless of them trying to confuse it with 3SF and 2SF, we know what it means. Now what we need to do is to look at the VL value. So the V lower value is here. This is the number that we're going to put to here. We need to consider the G upper bound, which is over here. That's going to go into there. What I'm going to do in this particular question, I don't need to rub that out and put it in there because we've got enough space here, inshallah, so we'll do it here. We'll carry on the question. So V lower bound. V lower bound we said is 24.35. And then we have 2 times by the G upper bound. Well, the G upper bound was 9.85. So it will be 2 times by 9.85. Okay, so that's V lower bound squared. 2 times by G lower bound. G upper bound. So that will give us HL. Now what we need to do now is use the calculator and work that out. Check that video. That's looking nice and clear. Alhamdulillah. Okay folks, right, let me drag the calculator back. This screen onto this screen. Oh, hang on. Oops. Okay folks, that's just the calculation on the previous question. Now we can do our new calculation here. So let's put this, all of this, into here. So first of all we need a fraction button. So, okay, right, I'm gonna, alright, I can't actually see the calculation fraction button there at the moment. Okay folks, you're gonna have to bear with me for the moment while I jig this around a bit, get up here actually. Maybe down to this side. Okay. Right, there we go, 24.35. So we need a fraction button. Fraction button's here. 24.35, you have to type that in now. 24.35 squared. Squared. 24.35 squared, that matches here. Bring the replay down to the bottom, so we can type in 2 times by 9.85 over here, press replay. So it's now 2.2 times by 9.85. Okay, so what we see here as the calculation is exactly what we see here. 24.35 squared is here, divide is here, 2 times by 9.85 is here. That's it. Now we press EXE for give us an answer. That gives us 30.097. And so on and so on. Right, let's have a quick look if how many significant figures they want us to give the answer to. That's the answer. I'm going to move the calculator away for the moment. And give your answer correct to 3 significant figures. So they've stated that they want the lower bound and they want 3SF. So there's the answer for the lower bound. H lower is equal to this. So we need to give the 3 significant figures. First, second, third significant figure. That's my last digit. That's my decider. If this number here is 5 or more, we add 1 to the last digit. So 0 add 1 is 1.0, add nothing is 0, 3 add nothing is 3. So the final answer is 30.1 is the answer for H, the height H in meters. So this is going to be our H. lower in meters. Done. So 3 significant figures. Okay folks, these are the 2 questions that was missed out from the original video due to, as we said earlier, some technical issues with lighting and lighting saturation in that video. It was a beautiful video made with my students. That was a live video. I hope this video that I'm making later on the week is as good, hopefully. I mean, okay, you can't hear me talking to any students because they're all at home in bed. Okay.